Hello, good morning students. Today I am going to discuss about thermodynamics. It is helpful for crash course, fast revision. So, thermodynamics. Here I am not going to explain about the derivations, all those things. This is only helpful for crash course. It is the fast revision only. So, here I am going to consider thermodynamics. First thing, what is the thermal equilibrium? Thermal equilibrium. Suppose if I am going to consider the two bodies A and B maintain at two different temperatures T1 degree Celsius and T2 degree Celsius and both are connected. Suppose I am going to consider T1 degree Celsius is greater than T2 degree Celsius. At the time heat flows from high temperature body to low temperature body. So heat flows from high temperature to body to low temperature body till both attains the same temperature. Till both bodies attains the same temperature. After that what happened? After some time its temperature may be T1 dash, its temperature may be T2 dash. Both temperatures are same after some time. So T1 dash is equal to T2 dash. At this condition we call it both bodies are thermal equilibrium to each other. And the next one is first law of thermodynamics. First law of thermodynamics. Generally, any gaseous system consists three parameters: pressure, volume, and temperature. If suppose this is called state of gas. If suppose the state of gas changes from P1 V1 T1 to P2 V2 T2, then we call it is thermodynamic process. Thermodynamic process. So in any thermodynamic process, maybe any one of the parameter will change, or two parameters will change, or all parameters will change. Anything is happen. That means pressure may change, volume may be changed, or pressure and volume may be changed, or all the parameters may be changed. Anything is possible in a thermodynamic process. Generally, what is the first law of thermodynamics? Total energy in any thermodynamic process is constant. That is the first law of thermodynamics. Total energy in any thermodynamic process is constant. That is only first law of thermodynamics. So mathematically, how we are going to write the first law of thermodynamics, we will see. Suppose if I am going to consider for any system I am going to give some heat energy, and it is converted as two things. One is some part is utilized to do the work by the gas on the system, and remaining heat energy utilized to increase the internal energy of the system. This is the first law of thermodynamics. Mathematically we are going to write, and it is also written as Q is equal to W plus delta U. This is the differential form. This is the normal form. We are going to write in two different forms. First law of thermodynamics. If I am going to see the sign convention, suppose work done is positive or negative, anything is possible. If work done by the system, work is positive, work done on the system work is negative. Why? Because if I am going to consider a system here, closed system, this is the gas. If I am going to give some heat energy here, work done by the system means what will happen? This piston move from here to here. At the time what will happen? Your volume will increases. In case of work done by the system, what happen? Volume increases and work done is positive. If work done on the system means what will happen? This is the initial position of the closing plate and this is the final position of the closing plate. At the time what will happen? This is the initial volume and the shaded region is the final volume. When compared to the initial volume, final volume decreases. So your volume decreases. So work done by the system, volume increases, work done positive, work done on the system, volume decreases, work done negative. This is the first sign convention. And second sign convention. dq, heat energy. Heat absorbed by the system we are going to take as positive. Heat lost by the system we are going to take in negative. And next one, internal energy, change in internal energy. Suppose I am going to take the change in internal energy plus when internal energy increases. Internal energy of the system increases positive. Negative, when I am going to take the negative internal energy, if change in internal energy is negative, when if internal energy of the system it decreases. Energy decreases. So these are the required sign conventions to solve the problems. First law of thermodynamics. Next one, factors in thermodynamic process. Factors in thermodynamic process. Suppose you observe, I am going to give some heat energy to the system. Suppose consider this is the system. So I am going to give some heat energy to the system. At the time what happened? 1 mole of gas, consider 1 mole of gas. And to rise 1 degree Celsius temperature, whatever the heat energy required, that is called specific heat, molar specific heat. Take the 1 mole of gas to rise 1 degree Celsius temperature. What is the heat energy required? That is the molar specific heat. So it is denoted by C simply. So suppose I am going to consider, I am going to give the heat energy. So number of moles and specific heat, rise in temperature. So this is the formula for heat energy. So if suppose I am going to consider mass, at the time I am going to consider specific heat. So this is also heat energy formula in terms of mass and specific heat. This is the in terms of number of moles and molar specific heat. Suppose, what is CV and what is CP? Here CV means what? Molar specific heat at a constant volume. That means take the 1 mole of gas and rise 1 degree Celsius temperature at a constant volume. Then the heat energy required we call it as molar specific heat at a constant volume. What is the meaning of CP? Molar specific heat at constant pressure. Take the 1 mole of gas, rise the 1 degree Celsius at constant pressure. So that heat energy generally we call it as molar specific heat at constant pressure. So how to write Cp and Cv in terms of degrees of freedom? In terms of degrees of freedom, if I am going to consider Cv, so F by 2 into R. R is the universal gas constant and F is the degrees of freedom. Degrees of freedom. So these degrees of freedom is different for different molecules. Suppose if I am going to consider monoatomic gases. So degrees of freedom values for different gases. Monoatomic gases 3. Diatomic gases or triatomic linear molecules. Triatomic linear molecules. Diatomic or triatomic linear molecule gases. We are going to consider degrees of freedom 5. Degrees of freedom 5. Triatomic non-linear. Triatomic non-linear molecules are polyatomic. We are going to take in degrees of freedom 6. Degrees of freedom 6. And here, suppose at high temperature, suppose these are all at ordinary temperatures. At high temperature, diatomic or triatomic molecules, diatomic gases or triatomic gas molecules, linear gas molecules, triatomic linear gas molecules. Along with 5, 2 more vibrational degrees of freedom will be present. Totally 7 degrees of freedom. At high temperature, diatomic gas or triatomic linear molecules will have the 7 degrees of freedom. 7 degrees of freedom. If mentioned in the problem at high temperature, then take this one. Otherwise, in any case, low temperature or you not mention the temperature matter, just you are going to take in any, not discussed about the temperature in the problem also, take the 5 only degrees of freedom. Okay, if suppose Cv in terms of degrees of freedom F by 2 R, Cp in terms of degrees of freedom F plus 2 by 2 into R, F plus 2 by 2 into R. This is the degrees of, in terms of degrees of freedom Cv, in terms of degrees of freedom Cp. Here U, R is the universal gas constant, F is the degrees of freedom. Degrees of freedom. We know that gamma is equal to Cp by Cv. Gamma is equal to Cp by Cv. So, the gamma is the ratio of two specific heats. Molar specific heat at constant pressure to molar specific heat at constant volume. Of course, what is Cp here? So, F plus 2 into R by 2, F by 2 into R. So, F plus 2 by 2 into R, Cv is F by 2 into R. R get cancelled, 2 get cancelled. 2 get cancelled, then what remains? F plus 2 by this F. So 2 cancel, R cancel, F plus 2 by F. So this is what? Gamma in terms of degrees of freedom. In terms of degrees of freedom. And most important relation between Cp and Cv is Cp minus Cv is equal to R. We know that. Cp minus Cv is equal to R. And in terms of gamma, Cv is equal to R by gamma minus 1. In terms of gamma, Cp is equal to gamma times R into gamma minus 1. These are the required relation to solve the problems. Next, if I am going to consider dq is equal to what I said, n c delta t. So I am going to get the formula for dqqu udu dww. We'll see. So we know that dq is equal to nc delta t. nc delta t or nc dt. nc dt. Suppose if I am going to consider integrate on both sides, then integral dq is equal to nc integral dt from t1 to t2. Then this is q is equal to what? Q is equal to nc integrated t2 minus t1 we are going to get. This is about one of the equation. The next one, if I am going to consider u value in terms of degrees of freedom, f by 2 into n or t. F degrees of freedom, n number of moles, r is the universal gas constant, t is the absolute temperature. So if you require du, then f by 2 n or dt. F by 2 n or dt. But we know that f by 2 r. Is equal to cv. Replace f by 2 into r with cv. Then what is du now? Du is equal to replace f by 2 into r with its equivalent cv. Then n cv dt. This is the internal energy formula. Change in internal energy formula. Change in internal energy. NCV dt. Next one, work done. We know that work done is equal to PdV. If I am going to integrate on both sides, work done is equal to integral P dV from V1 to V2. Then work done is equal to what? P V2 minus V1. My dear students, if you like this video, please share, subscribe and share it. My dear student, don't forget to subscribe, share and like. I will continue the thermodynamics in second video. So I'm going to do small videos and I'm going to complete the thermodynamics completely. In next video, I'm going to do how to solve the problems based on first law of thermodynamics. My dear student, this is the helpful for crash course for fast revision. And remember, in the next video, I'm going to explain how to solve the problems based on first law of thermodynamics. And I will do a small videos for fast revision. I'm going to complete within 10 to 12 videos thermodynamics. Thank you, my students.